Okay, so at some point in your life, you may hear the term standard algorithm when it comes to math. Standard algorithm is just doing an operation the paper and pencil way. Like no models, just the straight multiplication, addition, subtraction, division. So you've been doing standard algorithms with basic facts and with addition and subtraction. That's where you just on paper do 43 plus 27. 3 plus 7 is what, class?
9.
3 plus 7 is what, class?
9.
10. Regroup the 1 to the tens place. 4 plus 2 is what, class?
6.
Plus 1 is,
7.
which means that 43 plus 27 is
70.
70. That's standard algorithm. Pencil and paper, pen and paper, whatever. So what we've been doing so far is we've been using models to multiply 2-digit numbers by 1-digit numbers. Well, today, you're finally going to learn for real how to just do it the pencil and paper way. However, we won't see any regrouping yet. We'll do that. We're going to do a little bit more models, and then we'll do regrouping. Because the importance of models, the reason we do them first is because it shows you why. You may know that to find 22 times 2, you multiply 2 times 2, which equals 4, and then 2 times 2 again, which equals 4. But if you don't know why 22 times 2 is 44, this isn't going to help you much when we stop doing multiplication for a while because we're moving on to another subject and then we come back to it. You may not remember. The importance of models is so that you know 22 times 2 is 44 because you're taking 22 objects and repeating it 2 times. And then you know if you take 22 objects and repeat it 2 times, you have 10, 20, 22, 32, 42, 44 objects. That's the importance of models before the pencil and paper way. Because now that you know, 22 times 2, I'm taking 22 objects and repeating it 2 times. Oh, that's 44. Now, you can do it the paper and pencil way. Once you learn why the answer is what it is, then you can do the quick pencil and paper way. But the why is the most important part. Knowing why is what's going to make you remember this when you come back to it in 5th grade. And then when you come back to it in 6th grade. And then when you see it again in 11th grade. And then when you see it again in calculus, your junior year of college. And then when you're on the job and you have to figure this out, you remember it. Because you remember, 22 times 2 is 44 because you're taking 22 and repeating it 2 times. Knowing the why will make sure that you understand it forever. So, let's go ahead and look at example 1. Finger or pencil on example 1. Yes, Carla?
There's something underneath the title.
I know, but it just says place value can help you multiply. Well, place value can help you do anything. Because whenever we're doing any operation, addition, subtraction, multiplication, or division, place value is the first place we look. We know that with addition, subtraction, addition and subtraction, where do we start? What place do we start? If we're doing addition or subtraction, what place do we start in? Ethan, if you want to volunteer, you can raise your hand. Just make sure it's in front of the camera. Colin.
The ones.
The ones place. In addition and subtraction, we always start in the ones place. Multiplication is the same way. So, now, everybody, finger or pencil in example 1. That's what they mean by place value can help you multiply. You start in the ones place, then you move to the tens place, then to the hundreds, and so on. If your pencil is on example 1, I need to see your hand on your pencil. Okay. Read in your head while I read out loud. So, Ethan, remember, anything I write on the board, you write on your paper too, okay? Ann's mom buys 2 helmets. Each helmet costs $24. How much does she spend on helmets? Well, first, let's underline the question. How much does she spend on helmets? Do we see a word after how many or how much? Is the unit, the answer unit does? No, but if we see how much with no word after, and we know we've seen a number that represents dollars, what is our answer unit going to be? If we see how much, and we know one of our units was dollars, we know right away our answer unit will be what? Michaela? A dollar sign. So this means we can say, how much money does she spend on helmets? Does that mean the same thing? Listen to these 2 sentences. How much does she spend on helmets? How much money does she spend on helmets? Do those 2 sentences mean the exact same thing? Those of you shaking your head, no. Why? Zadie, why does it not mean the same thing? I want to know your thinking. You had a reason. Victoria, why were you shaking your head no? I want to know. You had a reason to shake your head no. So I want to know what that reason was so that we can talk about it. What was it? You had a reason. What was your reason? You don't just do something with no reason, and if you do, well, is that a good thing to do? Should you just do something for no reason at all? Those of you who are shaking your heads, yes. Why do those 2 sentences mean the same thing? Zari.
Because you just changed up does she spend and how much dollars. Spend just means dollars, just in a different word.
So if we spend, we know that we are spending. What do we spend? Guys, pay attention. I don't know why your eyes are in your desk or in your lap. You need to scoot forward. There's nothing in your lap that's going to help you with math today. What do we spend? Carla.
We spend money.
We spend money. If I say how much does it cost, am I saying if I go to a grocery store and I see a really cool, this is what I've been wanting, but they never have prices on it, so I don't buy it. I want one of those Halloween pumpkins, like they're not glass, but you know, they're like permanent ones and they have a pumpkin face on them. I want one of those, but they never have the price on it. So if I go up to somebody that works there and say, how much is this? Am I asking how much pumpkins is this? Am I asking how much pencils is this? I'm asking how much what? Michaela? The cost is. So if we see how much with nothing after it, but we know we saw dollars earlier, what can we automatically say is our answer unit? If we see how much with no noun after, but the rest of our problem had dollars somewhere, then we know what's our answer unit. Kingston, you had your hand up a minute ago. What do we know? Because if we go to a grocery store, are we going to say how much money is that? Probably not. Maybe. But we might say how much is that? So we know it's what? What's the answer unit? If we see how much with nothing after, but we know we saw dollars earlier, then we know our answer unit is what? Not spend, that's a verb. Colin?
Money.
Money. So our answer unit is money. Even though it doesn't say how much money does she spend, we know they're talking about how much money. Because if we look at the other sentences, the other nouns in this sentence, units are always nouns, right? Do you notice that? They're always things. Are we saying how much Anne does she spend on the helmets? How much Mom does she spend on the helmets? How much helmets does she spend on the helmets? Or how much money does she spend on the helmets? Which one are we saying? Class. Money.
How much money she spends on the helmets.
Okay, let's look at the rest of the sentence. How much does she spend on helmets? Do we see anything else that tells us 100% a unit or an operation? How much does she spend on helmets? Do we see any other words that tell us 100% this is our unit or this is our operation? Victoria. I don't see each in our question. Do we see anything else in the question? Please, Cullen.
No.
No. Please pay attention to the question I'm asking. Don't get ahead of yourself because then you're missing out. You're losing the patterns. No. So let's keep reading the sentence to see if we find, let's go back and reread the problem to see if we find anything. Anne's mom buys 2 helmets. I see a number followed by a noun, but do I know if that's important yet? Class?
No.
Not yet.
No.
Let's keep reading. Each helmet costs $24. What do I see there? What's the first thing I see in that sentence? Smith.
Each.
Each. Let's circle each because each tells us what? Smith?
That we are doing multiplication or division.
Multiplication or division. Good. What do I see? What is the next thing I see that I know is important? Michaela? Helmet. Why is helmet important? Where do we see it? After each, which means the noun that comes after each is what? Our other unit, which means we're looking for a number of money, amount of dollars, and a number of helmets. Do we see anything else that's important in just that sentence? Each helmet costs $24. Zadie? $24 because we know dollars is our what?
Is our unit.
Which unit?
The answer.
The answer unit. So we know $24 has to be important. Well, have we found our other unit yet? Class?
Yes.
No.
Not in that sentence, so let's go back and reread it again. Is the other unit in that sentence? Each helmet costs $24. No, so now we need to go back and read it again. Anne's mom buys 2 helmets. Well now, did we find something important? Cullen,
Yes.
what is it?
2 helmets.
2 helmets. Now the first time we read it, the first and second time, we didn't know if it was important. Once we read it a third time, we had found each helmet, so we know that we needed to find a number of helmets. Now let's figure out, are we multiplying or dividing? Well, if she's buying 2 helmets and they each cost $24, we know our answer unit is going to be dollars. So are we going to end up with a larger amount of dollars or a smaller amount of dollars? If she has 2 helmets and they each cost $24, is our number of dollars going to be bigger or smaller after we solve this? Aaron? It's going to be bigger, which means we're doing what operation? Multiplication, because multiplication gives us a bigger answer. Division gives us a smaller answer. So now we know our operation, we know our 2 units, so that means our problem is 2 times $24. Now, some of you, I told this yesterday. If one of our factors is dollars, what does that mean about our product? If one of our factors is dollars, what does that mean about our product? Kingston? Our product has to have a dollar sign. Now here we know that's true because we know our answer unit is money. But if we just had a regular problem that was $24 times 2 with no word problem, we would know $24, one of our factors is dollars, so that means our answer is going to be dollars no matter what. Okay, so now we need to find 2 times $24. Now before we were using either base 10 blocks to model, we kind of used arrays, but we're moving away from that, and we used area models. Now we're gonna look at the standard algorithm, the pencil and paper way. So what we're gonna do is we're gonna write this up and down. 24 times 2. I want you to use your pencil to go over top so that you have that muscle memory. Just make sure you can still read it. So trace the problem. Make sure that your 1-digit number, 2, is in what place? 2 is in what place? Zari.
The ones place.
The ones place. In the number 24, Zari, which digit is in the ones place?
The 4.
The 4. So that means when we're setting up our problem, we still are matching up places. So 2 is in the ones place. So we have to line it up with the 4 in the ones place in the number 24. So do not do this, because then you're saying 24 times what? Carla.
20.
20. And will that give us the same answer as this? Definitely not. Repeating $24 20 times will give us a much larger answer than repeating $24 2 times. So make sure that you are lining things up correctly. Okay, just like addition, step 1 is to multiply the ones. So if I take 4 and I repeat it 2 times, 2 times 4 equals what, class?
8.
8. So we have how many ones, class?
8.
8.
8.
Now, here's where it's different from addition. Because if it was addition, well, we would do 4 plus 2, and then we would do 2 plus nothing. But this is where multiplication is different from addition. Because even though this 2 in the bottom factor is in the ones place, when we get to step 2, multiply the tens. So I want you to retrace. We already know that the ones is 8. When we get to the tens, we're not saying this digit in the tens, 2, times nothing. We have to take this bottom factor, which is 2, and multiply it by the tens too. So multiplication looks like this. 2 times 4 is 8. Then 2 times 2. So we take this bottom factor and we multiply it by both digits on the top. Does everybody understand that? So we figured out that when we multiplied the ones, 2 times 4 was 8. Now we have to take this same 2 and multiply it by the 2 in the tens place. So 2 times 2 tens is how many tens? Ethan? Don't forget to unmute yourself.
4.
Very good. If we take 2 tens, how much are 2 tens worth? Michaela? 20. Ethan, don't forget to mute yourself again. 20. And if I repeat it 2 times, well, how many 10 rods do I have? Colin,
40.
how many 10 rods do I have?
4.
1, 2, 3, 4. How much is 4 10 How much is 4 10 rods worth? Smith.
40.
40. So that means if I take my 2 tens and I repeat it 2 times, I have 1, 2, 3, 4 tens, which is the same as 40. So that means 24 times 2 is what, class?
48.
48. So, Anne's mom spends what? Anne's mom spends what? Victoria. I can't hear you.
$48.
$48. So does everybody understand? The bottom digit, that one-digit factor on the bottom, you have to multiply it by both digits in the multi-digit number. Remember, a multi-digit number means a number with more than one digit. So you take that one-digit factor and you multiply it by both digits in the multi-digit number. But you have to go in order. So multiply that one-digit number by the ones first. 2 times 4 is 8. Then multiply the one-digit number by the tens. 2 times 2 is 4. If we check with an area model, well, we have our rectangle. 24 looks like what in expanded form? 24 looks like what in expanded form, Aaron? 20 plus 4. 2 times 20 is what, class?
40.
2 times 4 is what, class? 2 times 4 is what, class?
8.
40 plus 8 equals what, class?
48.
48.
So were we correct?
Yes.
Yes. I wish that they would let us do more of this, but whatever. I like this math book, except that I do feel like they do too much. Like it would be more helpful for us to write this than for us to just look at it. Because do you notice how when you write something, you remember it a little better than just looking at it? Because you've spent more time with it. And just like those anchor charts, the more time you spend with it, the better you what? Zadie? Memorize or remember it. Okay, is everybody with me so far? So are we only multiplying the one-digit number by the ones in any number? And then the rest we multiply by zeros. Is that how we do that? No. Remember, our one-digit number, our one-digit factor, gets multiplied by both digits in the multi-digit number. Okay. Helper number 1. Please stand. Okay. This sentence at the top says you can estimate to check for reasonableness. So in example 1, we checked by doing a area model. Well, you can also check by estimating. Which one's going to give you the exact answer, though? Which one is going to tell you 100% you are right or you are wrong? Carla.
The estimated.
Zadie.
The area model.
The area model. Because remember, an estimated answer is not the actual answer. You can just look at the estimated answer and say, oh, well, that's pretty close to my actual answer, so I'm probably right. But if you do an area model, you get an actual answer, right? You get, this is the answer. Which if it does not match exactly, means try again. An area model, estimation, you just get close. So if you made a silly mistake, but your answer's still close, you might be like, oh, I'm fine, even if you're not. So that's up to you when we get to where it says, solve, check your answer. Check for reasonableness. That's up to you. Do you want to use estimation, which gives you a close answer, or do you want to use an area model that tells you 100% you are right or you are wrong? Okay, everybody, finger or pencil on example 2. If your pencil's on example 2, make sure your finger is on, or your hand is on your pencil. Okay. Read in your head while I read out loud. 31 bikes were ordered from Jimmy's bike shop. Each bike has 2 tires. How many tires will Jimmy need for the bikes? Well, what is the first step when we're trying to figure out what a word problem is telling us to do? Colin.
Find the question.
We find the question and we do what with it?
Underline.
We're going to underline the question. Next step. We just underlined the question. What do we need to do next? Aaron. We need to see what noun comes after how many, how much, whatever. Which is what, Aaron? Tires. And what are we going to do with that word tires? We're going to underline it again. And we're going to label it AU, which stands for answer unit. So we know whatever our answer is, it's going to be this many tires. Okay. Now we need to look at the question to see if there's any other word that tells us the operation or the other unit. Do we see any other any other part of this question, just the question, that tells us which operation or what unit to look for? I'm asking. Do we see anything else in only the question that tells us something else to look for? Victoria? No. So we need to go ahead and read again. Let's read the first sentence again. 31 bikes were ordered from Jimmy's bike shop. Is there anything there? I see 31 bikes, but do I know if it's important yet? No. I'll keep it in mind just in case, but I don't know 100% if it's important. Each bike has 2 tires. Do I see anything that I know is important in that sentence? Zadie? We see each. That's the first thing we see. So what am I going to do with each?
You're going to box it.
Do we box the words that tell us? What do we box? We box what we're going to use in the problem, right? Are we going to use each in the problem? So what do we do with each? We circle it because each tells us the what? Does it tell us the number? Does it tell us a unit? What does it tell us?
It tells us either you're going to multiply or divide.
Which are examples of what? Multiplication and division are examples of what? Types of what? Zari? Multiplication and division are types of what? Everybody. This is open to everybody. Multiplication and division are types of what? I've said this word like a bunch of times this morning. Carla?
Multiple is same as addition and division is same as...
Please, Zari, please don't mess with your microphone. Nope, that's not what I'm looking for. There's a word. Multiplication and division are examples of what? Starts with an O. Kingston? Operations. Come on, guys, it's a pattern. It's a pattern. If you don't know the vocabulary, it's going to be hard to find the pattern. So each tells us our what? Does it tell us one of our numbers?
It tells us our operation.
It tells us our operation. Each can mean either what?
That one means multiply or divide.
Each means multiplication or division. Okay? Do we see anything important? Anything else that's important in each bike has 2 tires? Do we see anything else that is important? Michaela? Bike. Why is bike important?
Because
It's after each. The noun that comes after each tells us what? Our other unit. So what do we do with bike to tell ourselves, hey, we need this? We underline it. Is that it? What else do we do with it? We label it as OU. Why do we do that? To stand for our other unit. Is our answer going to be the number and then our other unit? Michaela. So is our answer ever going to be this many bikes? No. The answer is always the answer unit, the word that comes after how many. The other unit just tells us, hey, this is our other number that we need. Is there anything else in that sentence? Each bike has 2 tires that is important. Colin,
Yes.
what is it?
2 tires.
2 tires. What do we do with 2 tires?
We box it
We put it in a box. Why are we putting it in a box?
because we use it.
Who can help her out? Why are we putting it in a box? Where do we use it? Smith?
We use it in our problem.
We use it in our equation. Okay, do we see anything else in that sentence? Each bike has 2 tires. Class, you can show me. No. But do we have everything we need yet? You can show me. No. So what do we need to do? Go back and read again. 31 bikes were ordered from Jimmy's bike shop. Is there something important that we know 100% is important now? Zari.
31 bikes.
31 bikes. So what do we do with it? How do we show ourselves, hey, this is important?
We're going to box it.
We're going to put it in a box because 31 bikes is telling us part of our what? Sorry.
Equation.
Good. Okay. So now we have to figure out how to set up our equation. Well, we know our answer has to be blank tires. Some number of tires. In our problem, we have 2 tires. So we need to figure out, does our answer need to be bigger or smaller than 2 tires? Well, if there are 31 bikes and each bike has 2 tires, are we going to end up with a larger or a smaller amount than 2 tires? Ethan, are you raising your hand?
A larger amount?
A larger amount. So Ethan, does that mean we do multiplication or division?
Multiplication.
Multiplication. Good. So now we know we're taking our 2 box numbers, 31 and 2, and we're multiplying them. So we know our problem is 31 bikes times 2 tires. First step when we're checking with estimation is to estimate. Well, let's look at these numbers, 31 times 2. Are we going to estimate or round, the larger factor or the smaller factor? Michaela? The larger, because would it make sense to round this smaller factor? No, we'd round it to 0, which would give us the answer 0. And is that very helpful? No. So, 31 rounds to what? What place do we need to round it to? The 10. So 31 rounded to the nearest 10 is what, Michaela? 30. Michaela, do we do anything to our other factor? No. So now using basic facts and patterns, 30 times 2 is what?
6.
Is it 6? Is 30 times 2 6? If I take 30 and I repeat it 2 times, do I get 6? I'm not asking what the basic fact is. I'm saying what is the answer to 30 times 2? But you're using basic facts and patterns. 60. Because now that we've done this enough, when we do it together, we're not going to go through each step because it's like rounding. We shouldn't need to do each step again because you guys should have it. Do you understand that? So, 31 times 2, the estimated problem is 30 times 2. Using basic facts and patterns, we know 30 times 2 is 60. So that means our answer needs to be somewhere near 60 to be reasonable. So, let's set it up. We're going to set it up and down. Make sure we line it up. We line up our 2, which is in the ones place, with the 1 in the ones place in 31. And now step 1 is to multiply the ones. So we're saying 2 times 1. If I take 2 ones and I repeat them once, how many ones do I have, class?
2.
2. Because 1 times 2 is 2. So we wrote the product in the ones place. We're basically still using partial products. We just don't have to add them because we're already putting them here. So we multiply the ones. 2 times 1, 1, or 1 times 2 ones, either way, is 2. So we put that in the ones place. Now step 2, multiply the tens. Well, do we multiply our 10 by nothing because that's what's underneath it? No, because remember, we take our 1-digit factor and we multiply it by both digits in the multi-digit number. So that means we're taking 2, and then we have our 3 tens. If we repeat 3 tens 2 times, how many tens do we have, class?
6.
6, because 2 times 3 is 6. So we write that in the tens place. So Jimmy will need what? Ethan.
62 bike. Oh, tires.
62 tires. Now, our product, which was what, class? What was our product, class?
62.
62 is close to our estimate, which was what? What was our estimate, class?
60.
60. So is our answer reasonable? Class?
Yes.
Yes. Do we know if we're 100% right by using this estimate? No, but our answer is reasonable. Reasonable does not mean correct. It just means, okay, yeah, that could be it. Now, we went through this step by step. We made sure to follow the steps. We made sure we had our correct basic facts. So can we go ahead and say, yes, we're 100% correct, since we followed all the steps and we paid attention and we went slow? Can we say we're 100% correct? Yes.
Yes.
So if you estimate, as long as you've done every step correctly and you've gone slow and you've checked and you've made sure that you did the right thing, well then you can say it's reasonable, it's correct, I did it right. But if you went fast and you didn't check as you went and you didn't tell yourself, okay, yes, I've got it, well then maybe you might need to use area models. Okay, is everybody with me? Do not forget, in what we're doing today, this bottom one-digit factor gets multiplied by both digits in the multi-digit number. Do not forget that. That is the most important step. Otherwise, I would end up with this. If I just went by place value and I multiply the ones, 2 times 1, and then I multiply the tens, nothing times 3, and then I take off the 0 because I don't need a 0 at the beginning of the number. Are these numbers anywhere near each other? Definitely not. So do not forget, you multiply by both digits in the larger factor. Okay, helper number 1. Please sanitize, erase, sanitize. Okay, number 1. So we're multiplying and we're checking for reasonableness. Mason, number 1. Let's use estimation just because it's faster, but once you get to the independent practice, you can choose to check with an area model or estimation. It's your choice. But we're going to use estimation. So we're going to draw arrows. And 42, which place do we round it to, Mason? Which place do we round it to? The ones or the tens? The tens. 42 rounded to the nearest 10 is 40. Do we round our one-digit number, Mason? No. And we're going to make sure to line it up with the ones place in our multi-digit number. Okay? Using basic facts and patterns, 40 times 2 is what, Mason? That would be 40 plus 2, but using basic facts and patterns. So what's the basic fact? What's the basic fact in 40 times 2? Don't get ahead of yourself. Listen to my question. What is the basic fact in 40 times 2? Is that a basic fact? One number by itself? Who can help him out? Zadie, what's the basic fact in 40 times 2?
4 times 2.
4 times 2. Mason, 4 times 2 is what? 8. Now we count how many zeros are at the end of our factors. How many zeros are at the end of our factors, Mason? How many zeros? Listen to my question. You're trying to get ahead of yourself. How many zeros are at the end of my factors? There's 0 zeros. How many zeros? Count the zeros at the end of the factors. Who can help him out? Michaela. 1. There's only 1, Mason. So how many? So now we have to move them to the end of our product. Well, how many zeros were in our equation? Michaela, how many zeros were in the end of our factors? So how many get moved to the end of our product? 1. So Mason, using basic facts and patterns, 40 times 2 is what? So that means whatever this answer is has to be close to 80. Okay, 42 times 2. Mason, what's step 1? To do what? Every single time, no matter what digits are here, do we always do 2 times 2?
No.
Look at the example 2. What does it say? What does it say step 1 is? What does it say step 1 is in example 2? It says step 1, what does it say in blue? Multiply the ones. Well, in this case, we have 2 times 2. What is 2 times 2? 4. Now, step 2 is to do what?
Multiply the 10.
Multiply the tens. Does that mean I do 4 times nothing? No. What do I do?
4 times 2.
I take my bottom factor and I multiply it by the digit in the tens place. 4 times 2 is? So that means 42 times 2 is?
84.
84. Is that pretty close to my estimate? So am I probably correct? Yes. Okay, Michaela, number 2. 21 times 3. Well, step 1 is to do what? Or I'm sorry, not step 1, but the first thing we do is we, but before that, the directions tell us to check for reasonableness, so what do we do first? Estimate. 21, what place do we round it to? What place do we round 21 to? Do we ever round anything to the ones place? The tens. So 21 rounded to the nearest 10 is what? 20. Do we round our 1-digit factor? No. But we do have to make sure that we line it up with the ones place. Using basic facts and patterns, 20 times 3 is what? 60. So that means our answer needs to be close to 60. So let's find our actual answer. Well, step 1, multiply the ones. 3 times 1 is step 2. So we're doing what problem? 2 times nothing? 2 times 3, because we multiply it by the ones and by the tens. 2 times 3 is that pretty close to our estimated answer? So are we probably correct? Yes. Okay, number 3, 11 times 4. Well, that's sideways. Just like addition and subtraction, should we solve a multiplication problem sideways like this, Victoria? No, so what should we do first? We write it up and down, making sure that the ones place lines up. Okay, well first, since we're checking for reasonableness using estimation, what should we do? Okay, estimate. Which of our factors do we round? 11. 11, we round it to the nearest 10, which is what? 10. Do we round our other factor? No, but we need to make sure that we line it up. 10 times 4 is what? 40. Louder, I cannot hear you. Now, our answer needs to be close to 40. So let's do the actual problem. Step 1. I can't hear you.
Multiply the ones place.
Multiply the ones, which means we do what? What's our equation if we multiply the ones?
1 times 4.
Which equals?
4.
Step 2.
Take the tens place and
What is step 2? We
multiply the tens.
multiply the tens. Does that mean we do 1 times nothing? No, because we have to take this bottom factor and multiply it by both. So what are we doing here?
1 times
Which equals
4.
4. So our answer, 11 times 4, is what, Victoria? 44. Is that pretty close to our estimated answer?
Yes.
So are we probably correct?
Yes.
Yes. Okay, next one, 32 times 2. Carla, should we solve these sideways like this?
We should not.
So what should we do first? What should the very first thing we do if we have a sideways multiplication problem?
We should write it up and down.
Good. Let's write it up and down. 32 times 2. We're making sure to line up the ones place. Okay, we're checking using estimation. So what do we need to do next?
We need to estimate 32.
Okay, 32 gets rounded to the what place?
30.
What place is it getting rounded to?
Tens.
32 rounded to the nearest 10 is
30.
30. Do we round our other number, our one-digit number?
No.
No. But we line it up with the ones place. 30 times 2 is what?
60.
60. So our answer needs to be close to 60. Okay, let's find the actual answer. Carla, step 1.
Step 1. Multiply the ones.
Which means we're doing what equation?
We're gonna multiply 2 times 2.
Our bottom factor times the digit in the ones place. 2 times 2, which equals, bless you,
4.
4. Step 2,
Multiply the 10.
multiply the tens. Does that mean we do 3 times nothing?
No.
No, because we have to take our bottom factor and multiply it by the digit in the tens place, which means we're doing what equation, Carla?
We're gonna do 3 times 2.
Which equals?
Which equals 6.
So that means 32 times 2 is?
32 times 2 equals 64.
Is that close to our estimated answer?
Yes.
So are we probably correct?
Yes, ma'am.
Yes. Okay, any questions? Or do you guys feel good about it? Just don't forget. The bottom one-digit factor gets multiplied by both digits in the top factor, in the larger factor. Do you think that if we had 3 factors, how many times would you multiply the bottom number? I'm sorry, if we had 3 digits in our top factor, how many times would we multiply the bottom factor? If we had 3 digits in our top factor, how many times would we have to take our one-digit factor and multiply it? Smith?
3 times.
3 times. What if we had 4 digits in our multi-digit number? How many times would we multiply that one-digit number? Zadie?
4.
4. What if we had 5 digits in our multi-digit number? How many times would we multiply that one-digit number? Michaela?
5 times.
5 times. What if we had 156 digits in our multi-digit factor? How many times would we multiply our one-digit factor? Victoria?
156.
156. So your bottom one-digit factor gets multiplied by every single digit in the top. And whatever place you're multiplying, whether it's the ones, the tens, the hundreds, the thousands, that's what place your answer gets put in. Does everybody understand? Okay, this is where we will work on this later. We have 10 minutes to do independent practice now. You will get another 15 minutes after music. So go ahead. Make sure that if you have sideways problems, how do you need to set them up? Class,
Up and down.
up and down. You
down.
do have lots of room. Don't forget to check for reasonableness. You may choose. Would you rather estimate or would you rather do area models? It is your choice. Everybody wait, let's look at the back. Page 226. For numbers 14 through 16, you need to have the equation on the line with the answer, but where do you need to show the work? Michaela, on a separate sheet of paper. So when you get to the word problems, you need to do the work on a separate sheet of paper. You need the equation with the answer in the unit on the line. You need to show your work on a separate sheet of paper. Look at the homework. Numbers 1 through 5. Where do you think you show the work? Colin.
On a separate sheet of paper.
What? But look at it. Do you have to do a whole lot?
No.
So where should you show it?
On the page.
On the page. For numbers 1 through 5 on the homework, you may show the work on the page because you have plenty of room. But what about 6 through 9? Victoria.
Show it on a
show your work for numbers 6 through 9 on a separate sheet of paper. But what do you need on the lines? Zari?
Your equation.
Equation?
Your answer.
Answer?
Your answer unit.
And your unit. And then if there's any explaining to do, show that on the line too. Remember, if it says explain period, that just means show your work. If it says explain with any other words after, that means you have words, like a sentence at least. Okay, go ahead. Use your time wisely. If you have questions, come and ask me.